viewers, so thank you for that. Um, so yeah, today we have the Aeolus satellite launching on a Vega rocket, and we're still go. I believe we're about 30 minutes before launch. My timer is gone now, so I can't really tell you exactly the time. But today we're gonna launch on a Vega. This is a paper model. I built this few weeks ago. But anyway, so the rocket, this is a four-stage rocket. It's the 12th flight of it, and it hasn't had any failure since its maiden flight. So we have 4 stages. We have 3 solid fuel stages and 1 liquid fuel stage. The we have the P80, and then the Zafiro 23 and the Zafiro 9, and then the Avum upper stage. Um, the P20 or P80, it's called P80 because it burns 80 tons of propellant, and then the Zafiro 23 burns 23 tons of propellant, and then the Zafiro 9 burns 9 tons of propellant. That's pretty clear. And then the upper stage uses hypergolic fuels, which means they ignite spontaneously when they come in contact with each other. We're not supposed to see the live line. Yeah, we are, but the live stream of the Ariana space is not live yet. So I'm a little bit explaining the mission before it actually happens. The Zafiro 9 is the biggest single segment solid booster. No, it isn't. It's the P80. The P80 is the lower stage, and they're building a P100, 120, which also will go on the Vega C and on the Ariane 6, and that's the that's gonna be the most or the biggest single segment booster. So the ADM-Aeolus satellite is going to go into a polar orbit, which means it's going to orbit over the poles. It's going to be in a sun-synchronous orbit, which means when it, for instance, comes over the Netherlands at 12 o'clock, every time it comes over straight over the Netherlands, it's going to be 12 o'clock. Doesn't matter for where you are on the Earth. You always have the same time it passes over. So if it right now it launches, and let's say it comes over your place at 5 a.m., it will always come over your place at 5 a.m. But the instrument on it was so sensitive, so the instrument on the satellite, they, instead of flying it to Kourou, they shipped it to Kourou. And I think it's pretty ironic since it's going to go on a rocket, which is a pretty hefty flight, and then they wanted to ship it instead of fly it because it's so sensitive. What's your favorite rocket you have a model of? What's my favorite rocket? I don't really have a favorite rocket. I really like the SpaceX rockets, of course. I like the Falcon and the Falcon Heavy, of course. Who doesn't love them? But every rocket has its little thing which makes it lovable. That's the same like the Delta II has the 9 boosters, and that makes it really strange and fun in its own way. What's your thought on Falcon Heavy? I think Falcon Heavy is really cool, but in theory it can outperform the Delta IV Heavy, and I'm not going to go into the debate today, but it's a cheaper way of launching really heavy stuff, but as I said, Parker Solar Probe, which I have a model of it here, like Parker Solar Probe, but it wasn't able to fly on a Falcon Heavy for everyone who thought it was. It wasn't, because fuels and actually how efficient the engine is. That is why the Falcon wasn't able to launch it. Um, yeah, Blue Origin is also working on engine. I'm really looking forward to actually seeing the Blue Origin rocket land, and then the New Glenn, because they will actually land it on a moving ship, as I understand it. Do Arianespace have any plans to make a rocket that can land? Yeah, they are actually now, together with ESA, they are launching a research project. I don't know what it is, but they are gonna launch a rocket to 21 kilometers and then land it vertically again, and then eventually the systems will move on into or the Ariane 6, which will be a Ariane 6 evolved version, or a they're gonna make an Ariane 7, which will be reusable. Callisto, yeah, it's Callisto. I forgot the name. I think it will be stationary. What will be? Oh, the ship, yeah. I don't know, but on the animation they had it moving, so I'm not sure about that. Yeah. The live stream of the Arianespace just went live. I will wait for that till they actually show footage of the pad. But I will take you through this flight sequence. So we will have the first stage burn for 1 minute and 54 seconds. Then it will separate. So this will separate, and then this stage will fire. The separation and ignition happens at the same time. No delay, no coasting phase. Then the second stage burns out, they separate it, they have a short 20-second coast phase in between it, then they fire the third stage, and then a few seconds after they fire the third stage, they will separate the fairing, which is this part, the nose cone, that will reveal the satellite. And then after the third stage burns out, they separate it, they wait for 2 minutes, then about 2 minutes, then they ignite the AVOOM, so the upper stage, and that will last for 8 minutes, then they will cut it off, then they will wait till they're at the other end of the orbit, then we'll fire the engine again, and then eventually we'll cut off and release the satellite. Also, something I read in the press release, or in the flight kit, or the press kit, is that normally you launch a satellite in the sort of a parking orbit, and then go to the highest point of your orbit, and then circularize, so make it a circle, because it's sort of an X shape. But now they're going to do it the other way. Actually, when they cut off the engine of the AVOOM, they're at their highest point, and when they go to their lowest point, they actually lower their orbit to be in a circle. So that's a weird way of doing it, but I think it's a really kind of special way, this launch. Any questions? So yeah, right now is the questions time to ask questions. Yeah, there we go. We have live footage.
Now we are going to look at the launcher, the lightweight launcher of the Ariane group. It's 30 meters tall, it has a total mass of 138 tons, and a thrust at liftoff of 2,200 kilonewtons.
So, yeah, there it is.
With regard to our satellite that's under the fairing, as you can see, the client is the European Space Agency. Its mass at liftoff is 1,357 kilograms. Its mission is Earth observation and wind profiling. The prime contractor is Airbus Defence and Space. It will be on Sun synchronous orbit at 320 kilometers of altitude. So here we have a drone above the base. And so this International Space Station will be slightly above Vega. Back to Josh.
Where's the ESA stream? This is not the ESA stream.
Stefan, welcome. We have just a couple of minutes. We have two quick questions for you. The first one, this is the 12th Vega launch. What makes it special? C'est le 12e lancement Vega. En quoi est-il spécifique?
So you want me to answer in English or in French or in French-English? Okay, it's a specific mission because it is the 50th mission we deliver for ESA, and it is a very good illustration of our raison d'être, DNA if you want, which is to give Europe a reliable access and autonomous access to space. And
actually,
secondly, it is also very specific because this mission is dedicated to environment. You know that Aeolus is going to help us to better understand the wind. By better understand the wind, we are going to better understand climate change.
That's also why I do these
fight
live streams, because most
warming.
of these
So
streams don't
here
have
we also do what we want to do,
well,
which
one,
is to deliver services for a better life on Earth through space.
Very good. Okay, last question. Can you tell us a little bit more about the mission, maybe some facts and figures? Pouvez-vous nous en dire un tout petit plus sur la mission ce soir?
Okay, so it is 12 Vega we are going to deliver. We deliver it in partnership with Avio, with the prime of Vega. We have had 11 successful launches, and tonight it is the 12th one. This mission is going to last 55 minutes. We will have the 3 first stages, which are going to deliver during 6 minutes and a half. We will head towards the north, and we will have two boosts of the AVUM, and after 55 minutes we will deliver the spacecraft on a sun-synchronous orbit. All is green on the
okay.
The meteor is very good, the weather is with us, so the launcher is ready, the satellite is ready, so everything should be okay for tonight.
So what I said is, because I host these launches because I think I love talking about rockets. I think it's fun to teach you or tell you more about this rocket, this mission, this satellite. And how do you say tomorrow? Tomorrow.
Give you a very short and quick summary of all the events that are going to take place.
But also, they don't have an interactive host, so I'm the interactive host. I answer questions. I sometimes go into the discussion, and also we have you have a chat room. Yeah, so yeah, it's weird. I turned down the volume of the stream, but apparently my OBS thought it was okay to put it at 100% volume. Where's the regular lady we have?
That will take over, and shortly after, the fairing that protects our passenger will drop off, and we'll be able to see Aeolus, and finally the Zefiro 9 will also finish their work, and its separation will take place at 213 kilometers of altitude, and then finally the upper stage, the AVUM, with liquid
so yeah, we have so it travels around the Earth, and it will launch in Peru, which is above Brazil. It's just next to Suriname, and normally it's the man, this lady. No, it's a different lady today. But it will separate next to the coast of Australia, so it will have traveled halfway around your world in just under an hour, which is really fast. There you see the tower supporting the satellite, and behind it is the gantry. That's the building that actually protects the rocket and the satellite in it, which it's the building that actually drives over the rocket and then closes, so keep the doors closed to protect it from the elements. And then it just 3 hours before launch, 3 hours and 15 minutes, they open the doors, roll it back, and then they have their rocket ready to launch. Great to have you back. Yeah, I think it's great to be back too.
In 2015 and 2017. As the first wind profiler in space, Aeolus is a challenging mission. was supported for many years by highly motivated.
It does stuff and protects from the elephants. Yeah.
Result of hard work and perseverance. On Aeolus, preparation for launch was achieved in several steps. Early studies allowed consolidation of the performance required for Vega, given the satellite mass and its operational orbit. Dedicated meetings were held to review the key aspects of a launch mission. A visit to CSG was
How much does the satellite cost? I have
no
no idea. That's something I don't know. I can Google. I'm gonna find it out for you guys. I'm gonna turn him on.
Reviewed by customer and served to configure the launch base means. The launch campaign started early July, and as a final step, authorization for launch was submitted to the different regulatory bodies. We at Aerospike, along with our partners, Avio and ESA, in its role of Vega Qualification Authority, are proud to serve the Aeolus mission.
Pierre-Yves Bertin in the film mentioning the Aeolus team's hard work and perseverance, they needed it. There was a very, very long development time for this project. Some of the people working tonight have been on the project for nearly 20 years, so it's a big night for them. Pierre, back to you.
As you know, as you're an aficionado of our video transmissions, we often show you French Guiana's towns from the air. We've shown you Kourou, Cayenne, and Sinamari, and now it's
combining two neighboring settlements. In 1942, the two towns merged to become a single municipality.
The satellite costs, or that actually the whole program costs 481 million euros.
The Monsineri River runs along the village. Picturesque Creole houses
50 euros. No. No.
Monsineri is known for its mangrove oysters.
Yeah, $500
which
million.
today have almost disappeared. But an oyster farmer is trying to reintroduce them. On June 28, 2015,
So,
Monsineri
yeah.
opened its Eco Museum, a place full of
The
memories.
Arianespace has 3 rockets. We have the Vega, the Soyuz, and the Ariane 5. The Ariane 5 being the heavy lifter, then the Soyuz being actually bought from the Russians and being the medium lifter, and Vega is the light lifter. We're going for 12 out of 12 successes today.
A trip by seaplane is a great way to visit the municipality and discover the leisure resort La Mangrove or the French Guiana Zoo, which showcases the region's rich biodiversity.
I believe Vega is at the moment the most successful rocket from really being commercial, because the Falcon had 2 failures, the Atlas has had some partial failures, and hello, welcome to my stream. So yeah.
Our stage is set. I'm going to go back to the broadcast booth. While I do that, I'll turn you back over to Pierre.
So at T-4 minutes, the synchronized sequence will start, which means that they will, the computers will take over. I like your stream. Thank you. Which actually is the so they have computers on the ground controlling the rocket, and then computers in the rocket. Actually, the computers will on the ground will move everything over to the computer in the rocket, and then also the rocket will move from external power into its internal power, which means drawing power from the batteries. And also the satellite will go from external power to internal power. I don't know if it has already happened. It could be, but I know the rocket is only going to internal power at the last minute.
The choice to come by boat was made to avoid the pressure changes which occur during takeoff and landing of an airplane, and for which the payload is very sensitive. The satellite was transported to the S5 facility.
He's a Dutch person, I can hear.
And was unpacked the day after. A fit check was performed to verify the interfaces
You probably know what I mean with hearing your own people from your own country speak English and then have their accent and be like, no, that's not how you talk English. But anyway, that's not rocket, so I can tell you. Okay, while we wait for the rocket, it's gonna go into a sun synchronous orbit. This is not actually the satellite, but I will demonstrate. How do you say rocket launch in Dutch? Raketlancering. Anyway, besides from that, we a sun synchronous orbit. Actually, what I meant. Dang it. Okay, just one sec. My camera went out. Okay, I'm gonna fix that problem. In next stream, I won't have this problem because I'm gonna buy a different camera. So don't worry, guys. I'm back. Where are you from? I'm from the Netherlands. So.
In the following weeks, the electrical testing on the satellite was performed, and the preparations for the...
Those guys better hurry. Yeah, they... Imagine they would be preparing this and then be like, it sort of watches and then go like, we have 5 minutes till launch. Let's rush to the launch pad. Focus on. I don't live in a city. I live in a town. But yeah, the rocket is pretty powerful, and the next version of the Vega C, will actually have a different first and second stage, and a different fourth stage. So they except for the third stage, everything is going to be switched out. I love those suits. Yeah, they actually need them because hydrogen is really toxic. It only takes a few grams for you to breathe it in, and then they will burn your insides. It's really horrible. 4-stage rockets are not the future. And they might be. The Vega is pretty cheap. Yeah, more stages, more problems. Not especially. If you do it like Ithro, you will. You go from solid to liquid to solid to liquid. Yeah, this is the Verta configuration, but it's actually qualification flight. So I don't know if it's still qualification flight. I thought they were finished with qualification flights, but the Verta configuration is a qualification flight.
When it was tested in Aztec, back the Netherlands, and since 8 years I've been the full-time product assurance manager.
Okay, first time in Korea. Last question for you.
No, this is at least the third time that I'm here.
Okay. The space-based activities can be.
Yeah, I think it has to do because this sellout was actually planned to go on one of the first flights as a qualification flight, but then the satellite got delayed due to its instrument being not finished in time. So Verta actually means that it's a qualification flight. There's nothing different about a Vega or a Verta, it's just nomenclature. I haven't really been able to find a difference in the rocket. Yeah, it is. It says it is a Verta mission, so, but I don't think it is. I think they just didn't bother to change it to a non-Verta flight. Yeah, it's an acronym for something, but spaceflight acronyms are difficult. They're hard. If they go to the final countdown, I will turn up the sound because I want to hear the rumble of the launch. Are you Arco? Yeah, I am Arco. I'm Paper Arconaut because I thought it was a really funny thing with I build paper rockets, Paper Arconaut. So yeah. Yeah, it's a wind satellite and it got delayed by wind. Yeah, that's pretty ironic.
Under 2 minutes to go. Now I know you're going to go outside and watch the launch. Before you go, just tell me what's going through your mind right now after all these years on the project.
So yeah,
I'm feeling quite emotional now.
I'm gonna turn up the sound. I'm gonna shut up. Hopefully he's gonna shut up. I will still read your questions, but I will answer them after the launch. And if something comes up during the launch, I will quickly tell you. I'm gonna get back on that question.
The launch pad, and they will see Vega rising up and going toward the north. Martin is going to be out there. He'll be back, don't know when, maybe after the separation of the first stage, maybe a little later. And we'll get his live reaction and his emotional reactions.
Attention pour moins 1 minute.
DDO is going to announce the 1 minute mark now.
Top H0 moins 1 minute.
So we are into the final 60 seconds. Give us a chance to say hello to all our friends at Airbus Defence and Space in Les Mureaux, back in France, at ESA headquarters in Paris, Estec and Isaac and Esren, all of our industrial partners as well, as we look at the spectators gearing up for the liftoff. To all of you watching on the internet, also we all hope you're enjoying the evening. We're going to cut away and let you enjoy the liftoff. You will hear the DDO call out the final 10 seconds and we'll be underway. Enjoy the liftoff, everyone.
Good luck, Isa, good luck.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80 et décollage VV-12 Aeolus.
Wow.
La propulsion est nominale.
Wow. Whoa, I love those images. I hope we can see stage separation. That looks so cool. Stage separation on the Vega looks so cool.
DDO says all is fine on board. You saw Vega take off like a shot. I'm always amazed. It took her about 3 seconds to cross my computer screen here. 3 seconds, rising like an arrow. Surprisingly fast if you're used to watching the Ariane 5 liftoff. Ariane 5, of course, raises into the air much more slowly, weighs 6 times what Vega does, carrying 4 times as much propellant. Fine shots of her rising into the light clouds.
Like them.
All is well on board, says the DDO. Vega weighing 138 tons at liftoff, as she lifts off from French Guiana, beginning the 12th mission in her career. They call her the light launcher at 138 tons. But
So, okay, I hope this is okay. I'm gonna talk over
First
the
stage is
rocket.
running now. She weighs 97 tons. 88 tons of that are fuel. Most of any launcher's weight is propellant in any system that we're using today. The first stage
So yeah,
burns
20
its
seconds
engine
still
for about 2
burnout
minutes before
and
being jettisoned.
separation and ignition of the
You'll be
second
able to see
stage.
that as our camera is tracking Vega, because visibility is pretty good.
10 seconds.
First stage is produced in Colleferro near Rome, then delivered to the French Guiana plant here, where it's loaded with fuel and transferred to the booster integration building. You probably saw some of that on the video on the launcher campaign.
There you go.
And
Separation
Bradley
and
returns with a big
ignition.
smile on his face. Before
There we go.
separation is Martin Kaspers. So, how was it?
Incredible.
Tell us.
You see it, you feel it, and all the emotion that comes loose. It's great.
You're laughing. But
No,
did you,
no, it's not laughed. Yes, it's laughed, but also cry.
did you cry? Did you shed a tear?
I did shed a tear.
That's great. What impressed you the most? The sound, the speed, the light, what?
The light was so bright. I had not expected that from such a small launcher. I saw the Galileo or the Ariane launch, but this was much brighter than I had expected.
It's like Times Square out there. You can read a newspaper.
So the line you see on your screen on your right the upper. The circle is actually what's predicted, so that's a pre-flight predicted, and the cross is actually where the rocket is. And in the flight right now, you can probably see that the cross is a little bit above the line. That's completely normal. That's because they can't really predict what the SRBs are gonna do. They can just put out a little bit more thrust.
North going into a sun-synchronous orbit. Why do we need that sort of an orbit?
So yeah.
We need it for Aeolus, for the instrument for Aladdin. We want to have a dusk to dawn orbit.
We could see the Galileo launch was apparently visible in December last year.
Explain that to us.
It is basically you go north to south.
But yeah, we don't have real rocket launches in Europe. That's sad. So there we go. Now we have ignition of the third stage, and
ignition of the third stage.
There we go, ignition and separation of the fairing.
And coming up next, separation of the fairing. All right on time.
So there was a question about STTOs, I believe. Yes. Like the shuttle launch aircraft, I really hope they built the shuttle. I missed the shuttle. I wasn't really around then, but I really missed the shuttle.
So she needs more protection from the atmosphere.
Also,
of space, but not the first taste.
I really like shuttle launch. And SSTOs, that depends what your aim at it is, because there's one, they're gonna build a demonstrator with an Aerospike engine, which is really cool, but I don't really agree with their propulsion system, but that's a whole other story.
So how much fuel, roughly?
We have about 266 kilograms of fuel on board for the 3 emission. And the other thing is geostationary satellites are geostationary. They use less fuel to stay in orbit.
No, why is that?
Because they are geostationary, so they've got...
Because they don't go round in the ball of yarn.
Exactly.
Okay, very good.
Okay, so at the end of the burn of the third stage, you will see actually the flame pointing downwards, so that's because at the end of the burn it has way too much thrust, and the computer, to correct for it so it doesn't overshoot, just goes downwards, so a lot of thrust, or actually delta V, so the change in velocity is wasted pushing downward, but it's a way of controlling your rocket and making sure your highest point of your orbit is not going to be too high. Yeah, there you see it, what's happening. It's pointing downwards to actually get rid of the last seconds of propulsion.
Of what we're doing now is that you're in internal power, so you're draining the battery.
You're using some of that power.
Exactly.
Yeah, and I guess there's a case to be made for both sides. That's a hot debate.
I like the Skylon plane. No, there's something. They're Arca Space, I believe.
Excuse my Italian.
I have played Kerbal Space Program. I did. I actually did this launch yesterday. I recreated it in Kerbal Space Program.
The light launcher is the newest member of the Ariane family. Coming up on separation of the third
there we
stage.
go.
There you are, right on time. Confirmation.
Propulsion completed.
Now what's left of the composite on the left? The triangular bit is the Avo.
The solid propulsion phase is over.
That's what we call the platform. So that's basically containing all the equipment to keep the satellite in the right orbit.
And you can still see the composite on the right of your screen, and of course the spherical, the oval, white on the bottom is the
telescope. The telescope, which is part of the instrument Aladdin.
Aladdin, very good. We'll have more on the instruments coming up later. We have been picked up by our downrange tracking stations. There's one here in Galileo. The next one is the Bermuda Islands, where there's a NASA station. Bermuda will be tracking the launcher from the first Avom ignition to its cutoff on first pass around the Earth. See how we're going.
So this engine, it doesn't need any igniters. The igniters for, fun fact actually, the igniters for both Ariane, the Vulcan engine and the boosters of the, so all solid stages of the Vega rocket are built an hour's drive from my house, so one of the most important parts of the rocket is built in the Netherlands.
Upload data for the control of the spacecraft, and then we've got 2 ground stations in.
There's the while you're thinking. There's the beginning of the first.
There we go.
Burn. Okay, one is in
I saw someone commenting on that the thrust to weight ratio is not really high. I don't know who it was when the Ariane 5. Live you no, I don't live near Leiden, but they're not produced near Leiden. So. They're produced by APP propulsion systems.
An early U.S. missile called Scout, you may remember. Italy used
but,
the Scout from the 60s through the 80s. And
yeah, if you look at an Ariane launch profile, I will also host the next Ariane launch. That's a fact because it's on a Friday evening, so I will be able to host it. But you'll see this peak, then a dip, and then again a peak. That's because the rocket is really efficient, but it doesn't have a lot of thrust. So the boosters shoot it in this really nice arc, and then it follows the arc, and then goes down in the arc again. But somewhere past the highest point, it gains enough thrust because it has burned enough fuel and it has gained enough speed, so it can get so it's carried upwards again. So that's why you see this dip and then this. Well, your mama out, probably it's on a weekend.
The mission
so
aims to further improve our understanding of winds and help increase the accuracy of weather forecasts. But this new satellite is unlike any other. For example, its shipment to Kourou is by boat rather than plane, because the sudden increase in atmospheric pressure upon
so
landing
right now you
could
don't see a
damage some of its
cross.
delicate instruments.
That's because they don't have actually
Aeolus is also the
telemetry.
first space
They
mission to
are not
acquire wind
receiving
profiles on a
telemetry
global
from the
scale.
rocket, which is
This wind
normally
data is needed
perfectly fine
to
because
create weather forecast and
the
climate
first
models.
station again is
Today,
Saint-Hubert
meteorologists have to
in
analyze
Canada,
winds and weather
so it
balloons,
has to travel
tracking
a bit
clouds,
further
measuring
before it
temperature and
actually
looking at sea
gets
waves for surface winds. These
caught by
methods,
a
however,
tracking
have severe
station again.
limitations and give insufficient data.
All of these systems are not measuring all over the globe at all altitudes from the surface all the way up to the top of the
So
atmosphere.
this satellite will
In order
also
to
take
get
7 days
right,
to
they need
measure
more
the winds
observations.
over the
And
whole
this is
Earth.
where the Aeolus satellite will come in. Aeolus will measure winds from the surface or from optically thick
So you won't be
clouds
at school
all the
then?
way
No.
up to 30 kilometer.
Who goes to
It's
school
filling
in
the gap
weekends?
in the current,
Seriously, who
serving
goes to
system of the
school
Earth
at
for
Friday
forecast?
7
To detect
p.m.,
these wind profiles
8
from
p.m., I don't know,
space,
11
Aeolus
p.m.
uses a powerful laser called Aladdin, which stands for Atmospheric Laser Doppler Instrument. This instrument ejects an ultraviolet laser beam through the atmosphere. The air particles in the atmosphere, which are moving because of winds, reflect some of this light back to the spacecraft. By measuring the shifting frequency of this backscatter, Aeolus can detect the wind speed and profiles at different altitudes. Aeolus is the first satellite to use this technology in space. This is why its development has been a long and
You
costly
weird people.
process. The satellite is both a technological marvel and
Yeah.
a real challenge.
We pulse our optics 50 times every second, and this goes on year after year. And this intense pulse creates 1700 degrees on the optical surface of the optics and will fatigue the optics in long run. So we've had tremendous developments of the coatings of optics, and to withstand this high pulse, laser pulse ability. We are actually our own sun, if I may say.
Despite its more than 16 years of development, Aeolus overcame all difficulties because the mission was of great importance to the scientific community, who have requested data on global wind profiles for the better part of 2 decades. Due to its low altitude, Aeolus will have a lifespan of only 3 years. However, ESA hopes the technology will be continued on similar satellites in the future, as the understanding of wind profiles is
only
a
3
key
years.
factor
That's
for
pretty short
meteorological
for
and
a
climate
weather
models,
satellite.
which benefit us all.
Or actually, it's not a weather satellite, but I think they will probably be able to keep it on a little bit longer than 3 years.
Quebec, also used for Soyuz, by the way. It'll track Vega until the first Avalon cutoff. Now, Martin, in the film, they talked about 16 years development, overcoming difficulties. What sort of difficulties?
Well, at the beginning we had a working laser on the table, and then we put it in the vacuum chamber, and it stopped working.
Bad news.
Bad news. So then it's okay. We all thought that this is the end of it.
What? The end of the
When's next launch?
The end of the project, because we put the laser in the
wait a
vacuum chamber.
minute.
Within no time, the laser stopped completely working.
Okay.
So you thought it was the end of the project. Everybody
it
panicked.
is
We'll find out what Martin's
somewhere
teams
in
did to fix the situation after the next film.
Yeah, the 7th of September at 11:56. So it's gonna be 4 to 12 p.m. So that's 4 to midnight. There's gonna be a launch of a Ariane, and I will also be covering it. So if you like my stream, subscribe, hit that notification button, hit that bell, and you will get a notification when I'm going live for that launch. And follow me on Twitter. My Twitter is in the description. And if you, in the meantime, follow me on Twitter so you can see all my building updates from building rockets. And August 26th, I thought it was delayed again from the rocket. So follow me on Twitter, and if you have a question, just hit me up on Twitter. Question about rockets, about spaceflight general, hit me up on Twitter. I have the next spaceflight being the 7th of September. Because the Falcon is delayed again. The Telstar is delayed again till early September. So next up is actually going to be a Chinese launch, but I can't cover it, the Chinese launch. So the next flight will be an Ariane flight again.
So before the Airbus film, you were telling us
Thank you.
the project looked like it was
I see the viewers going down. So.
Well, we realized that
Anyway, I hit a 100 today, so I'm really happy.
Or vacuum, and that was the lack of oxygen. So we realized, wait a minute, maybe we need oxygen. We did a few tests, we applied oxygen, and guess what? It worked.
It worked. Now that was
hey, Samantha Christofretti. Yeah, I saw a tweet. She was there, but
one of the
I love her. Actually, a friend of mine bumped into her when he visited Aztec. He went there because he had a talk with a guy in 3D printing, and then he went to Aztec, and then he talked to the guy, and he was in a meeting, and then she stepped in. Out of nowhere, she stepped in. So.
Never flown before, so this is
I think it's a really cool story.
Must be very frustrating.
It's always on the edge of
cool
technology.
interactive commentary, nice work. Thank you guys. Well, thank you for watching and asking questions. Otherwise, I couldn't be able to do this. I'm gonna change my setup for next stream, so probably will be a little bit different. My background will be a little bit different. Camera will be different, so. I will still be working on my how it looks, but I thought I think I did a really good job.
If there is let's say a high winds or a hurricane or something
like this,
we can better predict
Vega.
where to put the resources in order to recover the situation.
Subliked and shared, yeah.
The 120th satellite.
Keep doing that.
By Aerospike by Airbus, getting back to 20 more Airbus spacecraft remain. in the Arianespace manifest.
So yeah, that's it. That's the first phase of flight over.
5th mission for Arianespace this year. We've flown 3 Ariane 5s and a Soyuz so far. The 299th launch for the Ariane family. Aeolus being the 27th.
The launch is not over yet, so stick around.
The 583rd satellite launched by
I'm gonna go ahead and go into the chat room and
going back to orbits, our sun synchronous
ask me
orbit.
anything. I'm gonna do an AMA. Ask me anything.
Heliosynchronous. Why is that?
It's well, the thing is, you want to have a global coverage with Earth observation spacecraft. So then.
So right now they're gonna put it into a what they call a barbecue roll. So you have the longitudinal axis, and they roll it around it to keep the temperature even over. It's like baking something on a barbecue, and then
you can relive those very exciting moments.
love the launch.
And she's gone from the screen, as I mentioned.
It's really quick.
We have several observation sites across the space here. Have cameras at most of them. They record the liftoff from their different angles. These shots we're seeing now. Many of the VIPs and invited guests are out there tonight. Have you seen a launch from there?
I just saw last in July the launch of the 4 Galileo spacecrafts.
And how does it compare with the one you just saw?
Yeah, completely different. I mean, the Ariane is much larger and slower, but the sound is more intense.
Yeah. And the sound from the launch base takes about 90 seconds to come here. Where we are in Jupiter. Is it the same for the Vega? Because I've never seen.
No, it's less of a delay between what you see and what you hear.
Does that have anything to do with the Doppler effect?
It went really fast.
No.
But it's always with the Vega that it goes really fast.
Well, I'm no physicist. All right. Over the fine shots of the replay, we're going to say a temporary goodbye. We're going to cut away for about 20 minutes while Vega enters a ballistic phase, waiting for the second atom ignition and the end of the mission after that. So enjoy the break. We'll be back at about plus 21 minutes.
Yeah.
See you then.
Okay, so yeah. That's cool. Are there questions? Hit me up with some questions. I have no pause screen yet, so I need to work on that. I like how they don't cover. Yeah, but it hasn't achieved its mission yet. It needs to go to the other side of its orbit, then lower its orbit. I don't know. I wasn't around then. I was -4. You're a funny guy. I'm 17, so. I was -4. When you put mostly I try and go ahead and put it up an hour before launch, but like the live stream and the link is probably on there. I can change it to a week before the launch, because after this I'm gonna change it to the Ariane. No, not yet. I'm gonna create a new thumbnail. It's gonna be the same as this one. Gonna grab pictures from the satellites, draw the orbit, and then put the whole flight sequence next to it. So I'm probably gonna put it up a week before, so everything is open, and then I'll go ahead and go live as soon as I can with a countdown timer, because I really liked it, because I can answer questions in the chat room and people actually stick around. It gathers up people, and I probably will, if it will get really busy in the coming streams, I might be able I might move the stream time to 45 minutes before launch, but that's probably in the future. I only have 50 subscribers right now, so not really. Countdown timers get, yeah. I will keep that. Depends on launches. I can do it for every launch, but some launches I'm not able to put it up really early because of school. Hey. Earth is a big cat, yeah. Sure. You did real. I enjoyed your commentary. Thank you. Thank you very much. And also, my stream is... I'm not sure if I'm gonna keep OBS. I probably will, but I need to figure out some stuff. It's gonna take me a little bit longer before I'm gonna settle with things. But I really liked it today. It went well, and then my camera shut down. That's the one thing I'm gonna have next stream, because I will have a different camera. I will actually get a webcam instead of a regular camera. Made my day. I thought it was okay. It doesn't rotate backwards, right? No, it doesn't. It's correct. No, it's not. It rotates backward. But that's just I can switch it around in my thing. Okay. Does it? Okay, I'm gonna let you see it again. Does it rotate backwards? No, it doesn't. It's correct. I pulled it off somewhere, and they said it was rotating backwards. So I just flipped it around. Maybe I didn't flip it around. Play backwards. No. YouTube. Nah. Probably have to start Patreon, because YouTube will get me zero money. Should I start Patreon? Question. Patreon or not? Yes or no? Question for you guys. Patreon, yes or no? Gonna have a little chat. So yeah, about the SSTO, they are, I can explain why. Arcaspace is building one, but their main propellant is gonna be hydrogen peroxide, which basically means, and then they decompose it into steam and oxygen, which basically means you have to live. You should, yeah. Okay, I'm gonna do that afterwards. But basically, what they have is a they have a monopropellant rocket. Monopropellants aren't that good. They're not good at creating energy. So I don't understand. They build an Aerospike, which is efficient, but then they sort of counteract their efficiency of the Aerospike with choosing a very their fuel choice is weird. I'm giving you permission now. The Aerospike does work, that's true, but their rocket, their propellant choice is peroxide, hydrogen peroxide, which is it decomposes, then heats up, and the pressure of the propellant and the steam creates the exhaust, which actually goes into the engine. But what they do is they choose a monopropellant, and they don't burn anything, so the energy, the temperature they create is not that high, so their therefore their exhaust, the speed of their gas leaving the engine is not that high, so the efficiency will be really low. So Yeah, it's just not for an Aerospike. No, it doesn't work. Yeah, it works, but it's not efficient. You could better choose an engine which actually burns two propellants. YouTube airplane button. Yeah. Yeah. So as you see, the orbit is slowly going down, which means that actually the orbit is they're gonna be lower, because they are at, yeah, their orbit is gonna be 320 by 320 kilometers, but they injected it at 360 by 120, which means at their lowest point of their orbit they need to lower their orbit again. And I think that this is the first time they're actually doing that with the Vega. Yeah, the Aerospike is actually, you know, the Laval nozzle. It's the bell-shaped nozzle. But if you take the bell-shaped nozzle and turn it inside out, you get the Aerospike, and then basically what happens is that the ambient air pressure, because engines are most efficient when the exit the nozzle, the exit area, that's the area of the bottom of the nozzle. The pressure inside that area is equal to the atmospheric pressure. So once you go up with a normal engine, and so let's take a Merlin engine, they have a pressure of about 0.9 bars. So it will be most efficient at probably a few kilometers up. And then their engine gets less efficient because their exit pressure is higher than the ambient pressure. But if you go to the Aerospike engine, the pressure of the exhaust will be about the same as the pressure of the ambient air, because there will be nothing that holds it in, so the plume will expand, and also the other way, so it will be more efficient along the way. And SSTOs that use Aerospikes are really efficient, and that's why I think the Skylon airplane will work. And I really like the idea of Strato launch, and I hope they're going to build the shuttle, the sort of SSTO shuttle. It's not really SSTO because they drop it from a plane. In England, we'd say, you know your onions. Yeah, I know my onions. I really do. I know my stuff. So yeah. Okay. Oh, dang it. Okay, I'm gonna do something. Do this. Okay, this is a really amateuristic, but I'm gonna do it anyway. I'm gonna grab something. Be back soon. I'm back. Wait, let me do this. Do this. Oh, no. I can do this. It's a bad Okay. Yeah, you can hear me, I know. I'm just trying to do this correctly, and OBS is giving me this large of a screen because otherwise it doesn't fit on my... I think it's okay. Yeah, there we go. Fixed it. I can try put a display of models behind me. I can definitely try. Should be able to do that. Yeah. And I wanted to talk about something, but I can't remember what I was going to do. Rockets. Oh yeah, I was going to show what I'm working on. So currently, what I love is rockets, space flights, Formula 1. So this is also my note of paper. It's not finished yet, but finding something else to talk about. So I'm gonna try and finish this soon-ish. So yeah. Also, Parker Solar Probe. Yes, it's so tiny. I love it. It's so small. Love it. Doesn't focus, but anyway. Parker Solar Probe. Yeah. Thank you. I'm not finished yet, but they are. That's nothing I can talk about. So I'm gonna talk about rockets. So this is the RS 68A main engine for the core booster of the Parker Solar Probe. Yay! Rocket, the Delta IV. But I bought very small magnets, and I'm gonna do something really cool.
Great.
With
Thank you for coming back to join us. We're still out on the terrace.
Go away. Go. Go. Okay. And this one, the H2B, I finally finished it, and I still need to build it and take pictures, but this is my model, I designed it.
And the upcoming film that we're going to show you is a review of flight
Crew
events.
Dragon. I haven't built a Crew Dragon. That's not mine.
Here, you saw that we lifted off on time 41 minutes ago. After liftoff, Vega's
but anyway, this is finished now, and it's gonna be up on Parthenis and my website soon. It's totally free. And next thing I'm gonna be working on, which also is gonna be live streamed, part of it, is I'm gonna build the drone ship from SpaceX, or actually design the drone ship.
Taking Vega to 213 kilometers when it's separated. Its pitch on separation is normal because it allows Earth to better control the thrust. We are now at 6 minutes and 30 seconds after liftoff.
anyone.
A short ballistic phase
It's
of
fine.
90 seconds
It's
followed
safe.
before
It's
the
perfectly
first
safe.
of
It's
ignition.
just as safe as the Boeing
For speed,
module is,
it
but
was 703 kilometers per second. The first
yeah.
Aerospike lasted 8
Get a
and
Skyline
1/2
model.
minutes. At the end of
I
its
don't think
burn,
there are models
Vega
of
was
it
flying at
yet.
350 kilometers
Yet.
When then
A
entered
good
the
thing I
ballistic
added.
phase,
I will
which
add it
lasted
to my
for
to-do
36
list.
and 1/2 minutes.
It's difficult though to build
The
it.
long ballistic phase will end at
I
H
will
plus
manage.
53 minutes. The AVUM will be at 320 kilometers altitude. The second AVUM burn will circle as Vega's orbit. It's a short, only 20 seconds roughly. Aeolus will separate from the AVUM at H plus 54 minutes and 57 seconds. Because of spacecraft mission specificities and its atmospheric laser Doppler instruments, Vega's trajectories was constrained in attitude through the flight,
well,
making it a complex mission.
even
Vega is
if
designed
they
for
fail in
constraints,
flight,
making it the perfect
the,
launch system for this kind of
Crew
mission.
Dragon is perfectly safe to pull it off.
Thank you to Alexandre Dallonneau
That-
for this
the rocket
recapitulation
is
of the,
the
mission. I'm
acceleration
still
that
on the terrace, still
the Crew
seeing
Dragon
the
can
setting sun.
provide
There are a few
is
clouds and some red
way
glow. We're going back to
more
Jupiter with
than
Josh.
they need for pulling the capsule away. It's perfectly fine. And if AMO 6 was a crewed flight, there would be and there would have been crew on it. The crew would have been fine.
The Earth Explorers.
Earth Explorers are one series of satellites which are dedicated to science. In fact, they are serving two purposes and are driven by two main objectives. One is to answer burning questions of science, and secondly, to explore new technology which has not been flown before and which is completely new. And Aeolus is the fifth of the Earth Explorers. We have already launched 4 of them.
Some of them here on the screen.
They're here on the screen, Goche, S-MOS, Cryosat and Swarm. So now the 5th one is Aeolus, and we keep still our fingers crossed that all goes perfectly well. But we also have some others in the pipeline, like Biomass, Flex, Earthcare, which are the next ones to be launched. So they're really addressing questions of science to better understand the Earth system as a whole.
How does Aeolus fit in globally to the ESA, the ESA?
But also the
observation,
last
programs?
failure
Quel est le
of
rôle de
Arianespace
Aeolus
wasn't
dans les programmes
really a
de
failure
l'observation
in my
planétaire
opinion. Yeah, it was a
de l'ESA?
failure, but it
Aeolus
wasn't
is,
a bad
is one of,
failure.
25
They could have lost
missions
the
which are under
satellites,
development in the
but
Earth observation program. In addition, we have
they were
14
just
missions in
inserted
operation.
into the
So
wrong
really we have a very strong
inclination.
portfolio of
And
different
for
missions, different
sets
satellites, either
14 it
development
didn't
or
matter
operation.
anyway because
So
it
Aeolus
was
is really the mission,
actually designed to
addressing
go on a
very
Falcon
important
9, but
questions,
then
which are
they
relevant
changed,
to
they switched to
society,
CES
better weather
satellites,
forecasts, better weather prediction,
so
but
for
also
CES
climate
14
modeling is a
went
key
on
application,
to the
and it
Ariane
really is one
rocket,
element
and
of a
it
larger
was actually
family, a
still
larger group
fine.
of satellites that do measure
Do you
various
have a 7.5
parameters.
more? I have the
should
Lego
say that the Earth
7.5.
Explorer family is the research mission, while we have also other
And
families
I
which
have
are more
one
geared towards
that's over
operation,
2 meters
the
tall
Copernicus missions and meteorological
in
missions.
Middelburg
Okay, how
at
about
our
the Sentinel
observatory.
missions? How does Aeolus fit into the Sentinel
can
missions? Quel est le
show
lien
you
entre
this.
Aeolus et les missions Sentinelle de l'ESA?
The Sentinel missions is a different type, different family of missions. They are
Uh.
operational missions. We are doing them with the European Union together. They are co-funded. The space component is co-funded by the European Commission and the European Space Agency. But they're really serving policy priorities of Europe,
I have
which
this.
are addressed with different parameters. We have launched today 7 out of the 20 Sentinels that are funded currently. And they really build up, I would call
That's
it the
what I
world's
have.
best, most ambitious Earth-observing system.
And the other
I should
7.5
also
is even
mention that
bigger.
in addition to the Sentinels,
Like
we
twice
have
this.
meteorological missions, which we are doing together with EUMETSAT, and we have the honor of having
No, this is
Vega
Lego.
with us today.
But the other
we're
one
also
is
working
paper,
ESA and
yeah.
EUMETSAT extremely well together in order to build geostationary and polar orbiting missions.
Okay, we're out of time. Josef Aschbacher from ESA. Many thanks.
Thank you very much.
We're going to go to a film now. What have we been talking about? The winds and the weather.
So, yeah.
We have a film on just that coming up. We'll be back with more. And the end of the mission and satellite separation. Don't go away.
So we'll be ending this after satellite separation because there is not really a use for to listen to all the people talking, giving speeches.
Are created
My
by the difference in
globe fell.
temperature between the equatorial regions and the poles. They are the
Yeah,
flow of
okay.
air from high to low pressure. As warm air
be there.
rises in the tropics, it flows towards the poles, where the air pressure is lower. On its way there, the air cools and sinks again, conversely leading to higher pressure and counterflows near the surface.
No, I like difficult
This
questions
way,
because it
winds are
gives me something to talk about, and
redistributing
otherwise I
heat
can
energy over our
just
planet.
archive it somewhere,
This process of
type
energy
it, and then
redistribution,
answer them
combined
later
with the
on.
Earth's rotation, generates the weather patterns we experience every day, and makes our planet habitable.
If we didn't have any winds in the atmosphere, then it would
Yeah,
be
it's
very,
okay.
very
It was
hot
only a
in the
sky
tropical
globe.
regions and very, very
This
cold
one.
in the northern regions. We would not be able to live in Europe because wind
Yeah.
is a very effective transport of energy. It's similar to the draft
Come on,
in
light
the
that
house.
candle.
When you open a window, you get flow in
last
and change
British
the
built
temperature in the house. The wind have the same effect
da-da-da-da.
for circulation. So
I don't
that's
know.
the main reason for the wind.
Since the dawn of time, mankind has been trying to assess winds and predict the weather. Where
I'm
in
gonna
ancient times
see.
farmers had to consult soothsayers and oracles, today we have more modern ways of predicting the weather. This is the European Centre for Medium-Range Weather Forecasts in Reading, UK. A partner of ESA in
when's
the
the next
Aeolus
school
programme.
launch?
They make global numerical weather predictions based on in-situ and satellite measurements. Their forecasts include detailed weather predictions.
Next launch is 7th September.
Less detailed
Follow me
forecasts for the
follow me
next
in
month,
Twitter. Link
and
is in the description if
indications
you
of
don't have
likely
Twitter.
trends up to a
Otherwise,
year ahead.
you will see
These
it on
numerical
my
predictions are the basis
thing. I
for
will
weather
put
reports
the time I will
worldwide,
go
and they
live
are
as
important for society.
starting time of
The
the
reason why
of this
it's
stream.
important for society is probably the most important reason is it can save lives because occasionally the weather is extreme. If we have extreme storms, and it's very important that we.
Were the Galileos the
warn
last
people about this
British
event.
satellites?
So the more
They were
accurate we
built
can make our
in
forecasts,
Great
the
Britain,
earlier we
right?
can advise
Or am I
people
wrong?
to
No, they
take,
were.
action to avoid being involved in new weather
Yeah.
disasters.
In
I
order
think
to
the
run
Galileo
weather
satellites were
models
the
based on
last British
numerical
built.
weather prediction, it is important to have sufficient and accurate data on the current state of the atmosphere, such as global
The Mars
wind
lander
and temperature,
Schiaparelli
as it is
crashed.
their
Okay,
interactions
that's
which
just
drive
a
the
fact.
weather.
The
Today,
Mars
this
Reconnaissance
data is mainly
Orbiter took
obtained
pictures of it,
by
and they
in
saw a
situ
few
measurements
tanks
of weather
scattered
balloons,
around, and
ground
then
stations, and data from
heat shield.
airplanes.
It crashed.
Satellites are used to measure temperatures from space and track winds indirectly through cloud movement and wave movement on the ocean
It crashed
surface.
and broke.
However, there remains a significant gap in wind data over vast land areas, the oceans, and especially between
Schiaparelli was
altitudes
also
of 10
okay.
to
Wait,
30
okay. The
kilometers,
Beagle,
where
yeah,
there's
Beagle
no
2.
in-situ data available.
Beagle 2 just broke.
So we need to know the winds in
Well, it
in
didn't broke.
remote
It
areas
actually
such as the
worked,
oceans,
but
because
then one of the solar panels
those
didn't
winds
unfold,
in
so
those
it couldn't
areas
communicate.
determine what the weather will be downstream in, for example.
Well,
over
the Americans.
populated
Story
areas, which is many
time.
days
The Americans actually
To
crashed
address this
the
need for
the
more
Mars
accurate global wind profiles,
something
ESA will soon
orbiter.
launch the Aeolus
They actually
Earth
crashed
Explorer
it because
satellite,
instead
with
of
the
feet per second, they did a burn in
processing the
meters
data.
per second.
If
So
Aeolus can
their
deliver the longer-weighted wind data,
closest point to Mars was too close, so they
hope more
burned up in the
satellites like
atmosphere of
Aeolus will be
Mars
launched in the future.
because they
For
converted
numerical
to
weather
wrong
forecasts,
the
it's
wrong
important to have accurate wind measurements
measurements.
today to predict the weather tomorrow.
Mars Reconnaissance. No, it was Mars something.
We have
I don't
been
know.
picked up, or we're going momentarily to be picked up by
It crashed and burned.
Norcia. Am I saying that right? New Norcia?
Yeah.
Station in Australia, not far from where Aeolus is going to be separated, by the way. She's going to be separated off the coast of Australia, I do believe.
There we go.
The French.
Now it's turning to
DDO's just
get
announced
the
that
correct
signal has
orientation.
picked up there. Now, just a word about the space base. The French chose
Yeah.
the French Guiana site when they wanted to build a new site in 1964. There were many possibilities, including Australia and Scandinavia. Kourou got the nod because it got a lot of advantages. A large opening on the ocean, low population density, nearness to the equator, and nearby hills where you can put installations for radar and telemetry. And you're looking at shots of the nearby hill where the CVI, also called the Real-Time Visual Center, is located right here. And there's a lot going on there.
Yeah.
These buildings are located just behind us here in Jupiter, in Kourou. And the hill is called the Montagne des Pères, the Mountain of the Fathers. Now, these teams are analyzing the data as it comes in from all the ground stations along Vega's flight path. Remember, we've been talking about Saint-Hubert and the Bermuda Islands and all the rest. These data are then treated to reconstitute the entire mission.
What would I launch?
And after that, the entire flight is recreated in figures from liftoff to well after satellite separation, then analyzed again in delay time. So all that to say that Arianespace has a huge
launch
amount of
another
information in its archives.
Rosetta type mission
launcher,
to come out.
going back to the first Ariane 1, Christmas Eve 1979, remember, has performed. The first UV laser.
That's what I would do if money was no
what is
object.
That's part of the light
Where?
Doppler,
yeah, exactly. Basically, we are the first spacecraft that brings its own light source
I don't know.
orbit.
Geftanen or
call out the second
probably some other
the
command.
Alum fourth stage. That's going to last for 20 seconds. Go ahead.
And then have a lander
So it's also
again.
something that Anders Elving, the project manager, has said in one of his videos, is that we are the first spacecraft to bring a light source on board. That's not done before. And it's quite unique in the sense
there
that
we go. That was
emit
cut
our
off.
own light.
I just completely missed it.
Extinction of the second
Extinction.
Okay, good. So we have our own light source. We emit and receive.
Okay, I missed that. 8 second burn. Oh, my camera quit again.
First, so all the other agencies and programs have tried it, and they stopped because of all kinds of difficulties, because the laser is so powerful that you get all kinds of issues.
We are coming up on separation in under a minute. Can I ask you what's going through your mind now? Are you as emotional as you were at liftoff?
Well, this is going to be the moment that Aeolus will stand on its own,
Okay.
become an adult, and go to work.
She's already an adult if she's 20 years old.
Yes, a young adult.
Yeah, or an old adolescent.
Yes.
All right, so you're feeling good.
I'm feeling good. Yeah.
Yeah. Go. Separate.
Quite strange, the feeling, and looking forward to the solar array deployment later on.
All right, this is.
It's really twisting and turning.
High concentration here in Jupiter and, of course, elsewhere around the world for the Aeolus people as we await separation. We focus. We've gone through separations before, but it's never quite.
Yay, separation.
Now there's the scheduled separation. You hear the applause.
Okay, yeah, that was it.
That's the scheduled separation. Looks good. Assuming we're going to have to wait until confirmation, of course, when we get the signal from the Troll station in Antarctica, but let's assume that all is well. So congratulations.
Thank you, Joshua.
Your work is just beginning, or is it over?
In essence, it should be over now, because it's been taken over by our colleagues in ESOC. If they need me, it means that they have an onboard problem.
So, yeah, you all guys. Thank you very much for watching. Follow me on Twitter. Follow me. Subscribe on YouTube. Hit that bell notification. I'll sometimes when I feel like it, I post something different, like the Falcon Heavy with music, because I thought it was really funny and really cool. Share and yeah, lots of love. Always, next live stream will be the Ariane 5. Exact times will be on my Twitter. I will tweet it, and it will also be on the live stream. Yeah, that's it. Thank you for watching. Great stream. Love you guys. Keep asking questions. Keep curious, and as always, ad astra to the stars.